Welcome, everyone, to today's Space News webinar. Our topic today is extreme weather. It's revolutionizing weather preparedness with space technology. And this panel that we have before you is a good one. Dan Lindsey of NOAA, Marshall Shepard of the Atmospheric Sciences Program at the University of Georgia, and Ray Goffer, who's the co-founder and chief strategy officer at tomorrow.io. This is going to be a great discussion. I've had a lot of interest on this topic. But first, before we get into that conversation, I want to say thank you to our sponsor today, BAE Systems, who has put together a short video for your viewing pleasure.
Hello, everyone. My name is Alberto Conti, and I'm the Vice President and General Manager for Civil Space at BAE Systems. We are the proud sponsor of this event today. Better predicting and mitigating the impacts of extreme weather events is one of the most urgent challenges we're facing as a nation. Over the last few months, we've seen historic floods in western North Carolina, record-breaking hurricanes in Florida, damaging thunderstorms in the Midwest, and wildfires in the Pacific Northwest. It's clear that no community is spared when it comes to the impacts of severe weather. Extreme weather events are devastating the local communities and our national economy, and unfortunately, they're only causing more destruction each year. The impacts of severe weather are worsened by climate trends like warming ocean and the increase in vulnerable populations living in areas prone to extreme weather. The urgency of this challenge demands the best technologies the aerospace industry and the broader weather community has to offer. NOAA is a global leader in environmental monitoring, responsible for operating our nation's most advanced weather satellites. The agency is currently developing the next generation satellite system to enhance forecasting technologies into the 2050s. At BAE Systems, we're proud to be a leading industry partner on this important program known as Geostationary Extended Observations, or GeoEXO. Today, we're going to hear from a panel of industry leaders and experts who will share insight into how advancement in weather and environmental sensing technologies can help protect lives and property. Now, I'd like to hand things off to our host and moderator, who will introduce our panelists and kick off today's discussion.
All right, that was a great introduction. We all care about the weather, right? At very least, because we have to stay ahead of it. But it seems to be getting more extreme. Seems is probably too much of a caveat. It's getting more extreme. Marshall, let's start with you. Before we get into the technology per se, set the table for us a little bit. Give us a sense of what the Earth is experiencing in terms of your vantage and sort of the vantage of how we're evaluating these, how we're surveilling changing weather patterns, and how it's been changing, and sort of how that sort of is juxtaposed to how it was maybe 5-10 years ago, if not longer.
Well, sure, and thank you for the question, and thank you to all involved in having this discussion. It's an important discussion, and I think it's contextualized by recent events like Hurricane Helene and Hurricane Milton, or heat waves and drought that we experience. So as I was listening to you, I don't really need to set the table because the Earth is setting it for us. Let me give you a bit of context here. I spent the bulk of my career before joining the University of Georgia at NASA's Goddard Space Flight Center in Greenbelt, Maryland. I was deputy project scientist for the Global Precipitation Measurement Mission, or GPM. And during my 12 years at NASA, I walked in that door as a meteorologist, trained at Florida State University. But as I really started to immerse myself into NASA's approach, they thought about the Earth as a system, so Earth system science. And so that contextualized for me the fact that hurricanes, wildfires, floods, drought, even cold events are not unique or isolated or independent just to the atmosphere. They are connected. And so we need technological advances and approaches that will allow us to observe the Earth as a system, satellites, for example, and other suborbital platforms. We need advanced computing capacity to deal with the large volume of data that new satellite systems like GPM provide, and how emerging systems like Tomorrow.io system is providing, and even the new, more robust platforms on the NOAA systems that Dan will talk about. I co-authored a report for the National Academy of Sciences about 7 years ago now, and it was looking at what we call attribution. That's a new area of science climate science where we try to make connections between today's weather and climate change. 10 years ago, if you'd ask a scientist, oh yeah, is there any DNA of climate change in that heat wave or in that hurricane? You got more hem and haw, and maybe you're seeing more sort of certain and statements now. I mean, we have the ability to run rapid attribution studies and other types of studies. I'll give you one quick example. Heat wave in the Pacific Northwest in 2021. I saw a study that said it was 150 times more likely to be that severe because of
Wow.
climate change. Yeah.
Yeah,
And
you know,
same,
I was just
yeah.
going to say, I mean, this is it's an interesting sort of parallel, right? Because typically when conversations are oriented around weather, you know, maybe the initial thinking is not necessarily space, but this is space news, right? And there's just almost an intersection of these technologies in such a profound way. You know, NOAA itself, I mean, I almost dare to say is somewhat of a space agency in a sense. I mean, yes, you have buoys and you have other aspects, but so much of what your orientation is oriented what's happening beyond the atmosphere. So Dan, maybe that's a good place to jump to you.
Yeah.
You're at NOAA, Office of Geostationary Earth Orbit Observations. You've got the eagle eye here. Let's talk about the technology. You know, where has this been going? Things like predictive AI, the ability to sort of suss out details and emerging weather patterns that lead, I mean, principally that lead to actionable efforts on Earth. So maybe that's where we start here. Where's this technology now? Where's it going?
Sure, yeah. So the satellites are really critical for observing really the entire Earth, mainly due to the fact that they can see, I'll use that in quotation marks, basically the entire hemisphere from their location. And so when we say geostationary, for those viewers who may not be familiar what that means you're at an altitude above the Earth such that the satellite orbits at the same rate that the Earth spins. And the field of view is the entire hemisphere. So you can essentially take pictures or collect data from that point constantly, and you can watch things that change very quickly. Hurricanes. So Marshall mentioned hurricanes Milton and Helene. We're able to use these satellites to track the hurricanes as they move over the warm water of the Gulf and then make landfall wherever they do. So yeah, the current technology, NOAA has 4 satellites that in the current generation called the GOES-R series that launched in 2016. And the instrumentation on those satellites is sort of next generation, is the beyond what we had before. For example, the imager, which is sort of the primary camera that's making pictures of these hurricanes, increased in resolution by a factor of 4 spatial resolution. That means we can see clouds, for example, that are 4 times smaller. And it went from 5 spectral channels to 16. And that really increased the information content of the data that we're collecting from
Give us a
space.
sense what that actually means in sort of practical terms. So for people who are not necessarily familiar with the terminology, what does that mean in terms of sort of precision?
Well, yeah, great question. It could mean a lot of things. A good example that's easy to understand is previously when we took a picture in the visible spectrum, it's sort of what our eyes see. Before this increasing technology, it was a black and white picture. And now, since we have multiple wavelengths, we can see it in color. Why do we care about color? Well, we're able to distinguish things like wildfire smoke versus clouds. Before, it all just looked like sort of a white color. Now we can see that the smoke is gray or brown compared to the clouds, which are more white.
Right. And I imagine that just the sheer latency question is dropping considerably. I mean, that's been always sort of a concern about sort of geostationary, sort of, so there's the long lag time. But as technologies improve, I imagine that also translates into sort of actionable policy recommendations on the ground.
Yeah, so the latency is really a critical aspect of geostationary. So sometimes we collect what's called 1-minute data, and that means, say that there's a hurricane and we zoom in on the hurricane's eye, we're able to take pictures and get that information to the forecasters within about 1 minute of when it happened. So
Yeah.
it's almost real time. It's almost looking at it like as it's happening, which is really quite incredible.
I remember seeing, and Ray, I want to get to you to talk about the business of this first, but I remember seeing some statistic of some sort about sort of the average sort of alert time when it came to tornadoes specifically being something like 5 minutes, you know, several decades ago, and that's almost doubled now in terms of where we're at. So, you know, being able to take shelter, or like the difference between 5 and 10 or 5 and 12 minutes is huge on the ground in terms of response time.
Yeah, absolutely. You know, the quicker we can get that information out, get it into the models, into the forecasters' hands, then the better job we're going to do in alerting the public.
Now, part of this, a big part of this, has to do with some of these, what's driving a lot of this, and I imagine the commercialization of new technologies. And Ray, this is where I wanted to talk to you because you're kind of our sole representative here on this panel, sort of the commercial sector. You're heading up tomorrow.io. This is a weather technology company which provides essentially real-time forecasting. Talk to me like a little bit more about the business of weather analysis, not only in terms of like how you're structured, but how it's changed. Because it strikes me as like there's been a real dropping of barriers to entry into this market, and how that translates in the capacity to test and iterate and innovate, and how different that is than what we've seen 5, 10 years ago.
Yeah, sure. So previously, whether private weather sector was really focused solely on repackaging governmental data, whether it's coming from NOAA or UK Met Office or any of the other agencies, and then providing some layer of services on top of it, whether it's your app you're seeing on the phone, which is really just repackaging the data and presenting it more easily, or adding people on the phone that sort of help you understand it for your business. What's changed, I think we kind of see ourselves really as leading that change over the past decade, is two things. One is we're really focused on insights. So not just giving you the forecast, which you can get on TV or just go on the NOAA website and see the forecast, but telling you what does the forecast mean for you and what you should do about it. And doing it at scale, meaning I can't have 10,000 people on the, on my side answering phones all day. So it needs to be a software tool that can do that. So our software platform or weather intelligence platform can essentially translate the workflow of a dispatcher at an airline and a farmer and a truck driver and tell to each of them exactly what they need to know, what they need to worry about, and what their recommendation for action is relative to the weather that's going to impact them. And so the ability to do that at scale is one big change. The other big change is you spoke about, barriers to entry. I think if you spoke to Marshall a decade ago or to Dan, the idea of a private company like us coming in and making a real big dent in the global sensing capacity from space was just ridiculous, right? Those systems cost billions of dollars. They take decades to develop. It's not something you can just do out of a small startup. However, we today and other companies in the domain are able to launch satellites and create changes in the modeling systems that are on par and in some cases even exceed what government programs that are 10 to 100 times more expensive do, and do it much faster.
Marshall, I want if you can address that because you two have worked together in the past. Talk about sort of that change, that sea change within the industry itself.
Yeah, I want to sort of address that because I'm a former president of the American Meteorological Society, the AMS, which is sort of the main professional organization within the field of weather. And I've been around long enough to know that the private sector and federal sector didn't always play well together, and there were always the sort of doorways of entry into certain spaces like modeling and satellite remote sensing and so forth. Those days are essentially over. In the past, I have served in collaboration with Tomorrow.io. I've worked with NOAA. I've been on their advisory board, and so I've seen the evolution of the weather, water, and climate enterprise in the sense that absolutely there's a clear and unequivocal role for NOAA, the National Weather Service, and some of the federal partners that I've worked with. However, there is a growing space for innovation and rapid development of technology that I think companies like Tomorrow.io and others are bringing to the table too. So I think we've kind of gotten over the training wheels of how to make that work. I don't think we're mature in those partnerships yet. I think we're still as a community learning. But at the end of the day, we know that weather forecasting, improved information, weather intelligence, whatever you want to call it, is vital to things like the economy, agricultural productivity,
Sure.
infrastructure, and resiliency. And so we have to utilize those satellite-based technologies, but also computational technologies like AI, machine learning, and deep learning.
I actually want to get into that technology a little bit more in a little bit more granular detail. And Dan, I'm going to lean on you to do this. Can you maybe just, we could step back a little bit and explain how, the geostationary operational environmental satellites work? When we're talking about monitoring and tracking things like fires and storms and volcanic ash, what features are you looking at? What are you detecting within some of these storms and hurricanes? And then to Marshall's point, how does that then feed, or how is that integrated into some of these machine learning models and these AI powered systems?
Yeah, so at the very basic level, what the satellites are doing, the instruments on the satellites are collecting light at various wavelengths from the Earth. And the light can either be reflected from the sun or it can be emitted by the Earth, one of the two. That's sort of in the infrared or in the visible. And what we do as a field in satellite meteorology is take that information, sort of that reflected or emitted light, and make an image out of it and figure out how to learn something from it. So, for example, say that we have a new forest fire that has popped up in the hills east of San Francisco. What we do is we're able to detect the emitted radiant energy from that fire and pinpoint down and say, okay, there's a new fire just detected by satellite at latitude X, longitude X. It may or may not have been noticed by the public and been called in by somebody from 911, and they can go in and, perhaps address the fire, put it out if they're lucky, or contain it if not. And then the smoke that then gets produced by the fire, the satellites are able to track that smoke based on sort of the reflected light of the sun off of the smoke. And that way you can say, oh, put out air quality warnings for places like San Francisco. And now where the machine learning comes in is, the sort of traditional way of doing this is forecasters are looking at images or looking at movies of the smoke, of the fires, of the hurricanes, and making decisions based on that. But what we can do now with machine learning is take all of this information that we were doing with our eyes and our brains before and let the model find a way to do something quantitative with that model. So for example, we have some experimental models that can do things like tell you the probability that a storm is going to produce lightning over the next hour. And you can imagine how that may be helpful for things like an outdoor event such as a football game.
Sure. Those lightning maps are crazy. Just to look at them as it almost looks extraterrestrial when you have a sort of a backed off view of the Earth. When you say this, I always kind of also wonder about sort of the delivery mechanism in terms of this guidance, because in the past, right, it's sort of funneled up in terms of a very structured process, and outreach to the media would naturally go through your local news station or the CNNs, the NBCs, or something to that effect. But given consumer-driven applications and modeling, and people are now going directly to NOAA, I think in a more profound way than they may have used to in the past, it strikes me that you can start addressing governmental concerns, business concerns, individual consumer concerns, or resident concerns in a much more direct way. Is that something that's like kind of baked into sort of the policy directive a bit more, or at least something you're conscious of?
Yeah, I think that the private sector, as you were mentioning earlier, works very closely these days, I think more so than ever, with NOAA and with the government agencies to get this information out as fast as we can. It's sort of a chain of things. We go from the observations to the models themselves to those that are making the forecast. But then, as you said, the private sector, it does a really tremendous and critical job of getting that information out to the public. One of the primary ways is actually our phones. What do most people do when they get up in the morning? They check their phone, check for text messages, and they look at the weather forecast. Well, that weather forecast comes from, where does it come from? It just doesn't come from anywhere. It comes from all sorts of this complex information that's getting fed into, say, the satellite data, the radar data, the surface data gets fed into models, and then, the models themselves are producing the forecasts that are then being distributed with phones.
And Ray, there's sort of a lighthouse effect to a lot of these new technologies. And what I mean is, like, you know, no ship captain can afford their own lighthouse on their own, right? But all ship captains benefit from them in a way. So like there's a role of government here in a pretty profound way in the development of the private sector in terms of growth of like weather analysis, and the business itself is pretty significant. And I wonder if you could sort of speak to that.
Absolutely. I think, Marshall, you once made the analogy of no potatoes, no chips, right? Uh, so the idea is that the government and private sector are quite synergetic, right? So basic weather information, weather forecast, life-saving weather information is and should remain a public good, right? Something that governments pay for and is given for free to the people, right? And that's what NOAA is doing. That's what other agencies all around the globe are doing, depending on their quality. I should mention that there is a huge gap in capabilities between NOAA and their equivalents in the developing world, right? Which is something we're, as a private company, trying to help solving with new technologies.
I'd actually like to address that point here before we
Yeah.
go on to the rest, because I think this is a really interesting point, and I'll just open it to the floor, whoever who wants to answer this. But you know, the nature of the data is only as good as those who use it, right? And so how does that process work? Maybe Dan, this is something that you can talk to, or Marcel, you can talk to this as well. But just the sharing of data across, because weather patterns obviously don't respect international boundaries, and yet certainly supply chains are all across these regions and are affected pretty dramatically. So how does that process work, and where are the stumbling blocks in it?
Yeah, I can just quickly state, oh, sorry. Hey, I'll just quickly say that a lot of people forget that the satellites that are looking at the US and looking at the hurricanes over the Atlantic, they're also looking at our international partners, and especially Central and South America, just due to the fact that they're sort of in our same hemisphere. We share that data freely with them. And, the meteorological agencies in Brazil, in Costa Rica, name your country, absolutely use this data and find it critical on a day-to-day basis to issue their forecasts and warnings.
Marshall, you and I talked about, because sharing data is one thing, operationalizing the use of it on the ground in terms of emerging storm systems, perhaps, is a totally different sort of ball of wax in terms of how you make use of all this new information that's coming down to get it out to businesses, to residents, and even to policymakers in a way. Where does that sort of rubber meet the road, so to speak, in terms of the challenges, particularly when you're looking either internationally or in areas, even in this country, that might be less developed or have less connectivity than sort of your major metropolitan areas?
Well, that was the whole point of us doing the Global Precipitation Measurement Mission, or GPM, back when I was at NASA. I mean, I remember developing this little graphic that showed, if you kind of looked at where all the rain gauges and radars were on the planet, most of them were concentrated in places like the US or Europe. The vast majority of the world did not have coverage for rainfall data, and it's needed. It's needed for agricultural activities, for water resources management, and so forth. And so satellites, again, most of the Earth's surface is not sort of suitable for putting a rain gauge or radar out anyway. It's mostly covered by water, or deserts, or mountain ranges. And so that's why we developed this mission to provide sort of quasi real-time rainfall estimates every 3 hours or so at fairly high resolution that can be used. These aren't just big science projects for us scientists. GPM had a mission to help society. And I think people like Rai and what they're doing are sort of taking that to the next level and faster. And so, but to your point, we have so many satellite systems, and small sats and CubeSats and big sats and GPMs. There's a lot of data. And so, oftentimes there's data overload. There's signal and a lot of noise. So I think you can't have this conversation about space technology and application without understanding and having a conversation about what are the new technologies that are going to be used to sort of reduce that data, if you will, into usable signal. And so I think that's where a lot of the conversation is right now.
That's actually exactly that's what I want.
I know Ray was trying to get in on this, I think so.
I was just going to go to you, Ray, on this, because I mean, I think that is like the crux of the challenge. I would think in a lot of this, like, how do you take these just almost overwhelming amounts of new data and use it in a sense that is not overwhelming human operators in the way that we have in the past? It almost strikes me as that you have to kind of progressively take human analysis a little bit out of the equation here, which makes people nervous, and certainly some of the models are only as good as the data they're trained on. So there's possibilities there for errors, and certainly in terms of changing weather patterns that we haven't seen before. So how do you sort of square that circle?
So absolutely, and I think the key, you touched on really good points. So one really important factor is really to understand the context at which your users operate, right? So I travel a ton to Africa, for example. And when I go there, I spend time with farmers who live outside of cities, and not in kind of what we are used to. And it's really important to go there and kind of see what they have, what they care about, what kind of weather they care about, and what time frame, what parameters they care about, and what access they have. In some cases, they only have a feature phone, not even a smartphone, and solving backwards from that. So you say, well, I need a system that can send a single sentence SMS in some, pretty, uncommonly used language to that region so that they can understand and act on it. So that's a huge part of the solution. But I do want to touch on the data because, we have this, I think it's a false assumption that we have too much data. Marshall talk about GPM, the gap that GPM was trying to solve, which we are sort of taking the torch and moving forward with it, is one of perhaps the biggest gap we still have in atmospheric measurements. We have maybe 10% of the globe with reasonable precipitation measurements, precipitation being one of the most important weather parameters ever. That cannot be solved from the ground because we can't deploy, thousands of more radars. It's an 8 years old technology. It's kind of where it's going to get. But it also cannot be solved with billion-dollar satellites because you need a lot of them. And if they're costing $1 billion, that can't scale. So
Right.
what we're doing is we're taking science that NASA proved, and that's another really great example of government and private sector sort of collaborating. The science of measuring precipitation from space was proven by NASA decades ago. Marshall was part of that mission, but they didn't really care or worked on like, well, let's get the cost down to, few dollars per scan versus many thousands of dollars. That's what we're doing. And so we're taking that same technology, shrinking the size of the instrument, shrinking the cost significantly so that we can get enough data that actually makes it useful for the farmers so we can get rid of, the man in the loop and we don't need all this interpretation.
Isn't that always the case? Maybe not always the case, but you have those within oftentimes government agencies or scientists who are doing science for the sake of science, or their own sort of iterations within their existing systems without any clear understanding of where the commercialization or the market application comes. And then it does come down the road, almost inevitably. Before we go on to the next question, actually, I wanted to ask you one more bit about sort of an AI component to this, but I wanted to send a sort of a reminder to everybody who's watching online here to put your questions in the chat, where we've got, probably about 15 to 18 more minutes of conversation with the panelists here. But in about a quarter to the hour, folks at Space News will collect a lot of these questions, send them to me, and we'll get through as many as possible. So if you have your questions, put them in the chat, and I will do my best to get to them. Okay, Ray, I wanted to get one more question on the question of the sense of, or maybe not so much a sense of overwhelming human operators, because if you were to kind of put your future hat on and look down the road, and I imagine it's hard to do that in terms of 20-year spans, but 5-year spans, you're certainly looking at these things, and the rapid pace of development with it and AI. Where's the role of human operators in this, in emerging areas, as you kind of push out into the future?
I think the role of human operators is not going to go away, but it's going to be much more about sort of telling the systems what to do and what to look at versus being the actual person that's looking at it, right? So you could think of, doctors training AI that's then going to be the one doing most of the diagnosis because it's going to do it better. But similarly here, we have all these massive amounts of data coming out of forecasting models, and the hints are there, right? There's going to be a storm, there's going to be a tornado. A
Yeah.
trained meteorologist can maybe see it and can maybe contextualize it to the user, but that cannot be done at scale. We have in our software tool today, in our platform, a feature called Gale, which essentially is a GPT-based tool that looks at the model and then tell you, well, you are a tracking dispatcher. Here's what you care about. You're going to care about icing on the road, and here's where the conditions for that are going to happen, without any human in the loop, right? That was not possible even 2 years ago. And imagine what can happen, 5 years from now with that kind of technology.
Could I just follow up on that really quickly?
Please, please.
Agreed. I mean, I'm just reading the New York Times as we're talking about a new AI system that I guess one of the big companies, Google or someone, has it. It is rivaling some of our best weather models. So I think we're in this era. We have to embrace it, not be afraid of the fact that there are going to be technological advances that I mean, in the same way that we embraced ensemble weather forecasting modeling as opposed to deterministic models where you just had one model forecast for one realization of the atmosphere, we went to ensembles and that improved things. Now we're taking a step forward. But I will say this, and I this isn't a shameless plug, but I do host a podcast for the Weather Channel called Weather Geeks. And I think both of these gentlemen have been
Plug away.
on that podcast. And so one of the things that we've talked about is even as we have this emergence of capacity and humans not in the system, in events where we have extreme weather events like Hurricane Helene or Milton, people still do want trusted human voices in some aspects of that messaging chain that we've found. And so I think that we have to embrace and harness the power of AI and machine learning. I will say, and we actually have research ongoing here at the University of Georgia, we have to be aware of the ethical issues around AI. I mean, AI and machine learning are inherently built on other people's data and other people's models because they're learning from large data sets. And I think we're still grappling with what are the ethics around that in terms of proper attribution. None of that should stop the train from leaving the station, but we should be aware of all of those sort of nuances as we do.
I don't know that we have a choice in a way. Just the nature of the technology is moving so fast. It doesn't seem like there's an option not to embrace this technology. That said, that's a great segue in terms of those questions. Not only the nature of stumbling blocks that maybe you, Dan, you can identify that NOAA itself is facing, but like looking at those ethical challenges and how you sort of factor that into day-to-day decision making and what technology gets integrated and to what extent it gets integrated, I think are real questions going forward, particularly at your perch and your helm over there at NOAA.
Yeah, the ethical consideration is really important, and like Marshall, NOAA is very much keeping an eye on that and very cognizant of the potential issues there. But at the same time, as you said, we can't ignore this technology. Ray mentioned earlier about the ability to take sort of the gigabytes or even the terabytes and petabytes of data that are being provided constantly to us. And I really do believe that AI is the way to take all of that information, some of which may not be being used right now, but those models are good enough that they can put that all together and find a use for it, whether it's improving the forecasts, doing a better job of issuing, say, the chances of a tornado tomorrow, something like that. And I think it's a technology that we can't ignore and we absolutely have to embrace.
Is there this also the sense? I mean, I have an opportunity to speak with a number of folks, particularly in the space industry, exclusively in the space industry and rocket factories, and different think tanks around the country, around the globe, and they kind of point to AI at least a little bit in the terms of not to take away from the paradigm shift that seems to be a part of all of these new applications. But a lot of these folks say, we've been using machine learning and algorithmically driven formulas for a long time. And it's just sort of this broader sort of adoption at the consumer level of these changes that have been going on for the past decade or so. And I wonder how much that sort of plays into sort of the reality of what you deal with day to day, Dan.
Yeah, absolutely. And more it's being used, like I said, and looking forward to the future, which is what NOAA is doing right now. We have to plan our future satellite programs way in advance. And I think one good example of that is the future geostationary program is called GeoXO. It was mentioned in the little sponsor video at the beginning. And so that's going to be the observation system from geostationary orbit that collects data from the early 2030s all the way to the 2050s. So we're talking, a 20, 30-year program into the future.
Mm.
As part of that, we're going to be adding some new instruments, several of which, 3 of the new instruments are being built by the sponsor who came on, BAE Systems, down in Boulder, Colorado. But one of the key instruments is something called a hyperspectral infrared sounder. And that's a lot of words, but what it really means is instead of collecting data in only, say, 16 wavelengths, it collects on the order of 2,000 wavelengths. And so there's basically, 100, 200, 300 times more data just from in the spectral sense. And we're really going to rely on both physical models as well as these statistical or machine learning type models on how to take all of that information and do something useful with it. In this case, what it's aimed at is doing a better job of characterizing the temperature and the water vapor in the atmosphere. And models really need to know what is the temperature and water vapor really within the entire troposphere in order to initialize the models and have the models do a much better job of issuing the forecast for, a few hours from now or a few days from now. So we're really excited about this system in the future. Sorry.
That sits right next to the flux capacitor. I think, right? In terms of how these technologies now get integrated. I wanted to ask a question that my colleague Deborah Werner of Space News had asked. We're going to go to the audience questions about 10 minutes, but she and I were communicating yesterday. And Ray, this is more of a question I think for you in the sense of sort of looking at what's possible in the commercial space. And she's basically asking, are there opportunities for commercial space weather companies to provide more products and more services than they're doing now? She gave this great example under the commercial weather data pilot program. NOAA's testing whether tomorrow IO's commercial microwave sounder data would improve weather prediction models. So address that question, then also maybe just address the broader question of how that and if that makes sense.
The answer is absolutely yes. The best analogy is if you ask someone like, I don't know, 10, 15 years ago, think of all the biggest inventions of our, tech inventions of our recent decade. I don't know, Uber or Airbnb or services or others, right? Reusable rockets, right? Was that somebody sitting at a government, agency saying, "Oh, we need that, and that's gonna, let's build that"? Government does really good, preliminary science and like gigantic missions, but a lot of innovation, most innovation comes from private sector. Similarly, when we started our mission, that was not on the decadal surveys. In some cases, when we went to people and said, "Hey, we're going to fly weather radars in space," people told us we're nuts and it's impossible and it costs $1 billion. Marshall was there. We have 2 of them on orbit. They work, right? They send data down. So point is absolutely private sector can do things that were considered unimaginable or just, far, far, far away and do them faster and cheaper. I don't want to discount government science, government innovation. Government is needed, and it's also needed as a customer, right? Because of that public good notion. But I would shamelessly pitch here that the commercial data budget should be 10 times the size that it is right now. It would still be a small fraction of NESTIS's budget, right? But the government gets so much more. Like our cost per scan for sounding is about 1%. Let that sink for a second. 1% of what you get out of ATMS, and the data is comparable. 1%. Show me another example where you have 100x improvement on cost performance ratio from a private sector mission, right? That's insane.
I mean, it certainly makes sense. I mean, also as a private company, you just asking for bigger contracts also makes sense. I would I would think. So there's there's a little bit of a go between there, but certainly that plays out.
Just to be
Um,
clear, though, just to be clear, it's not that the other space assets are built by not private companies. They are also built by private companies. I want to make sure that that notion is not like.
oh yeah. No, I'm just giving you a hard time when it comes to that. But I think there's a question when we talk about that specifically and talk about the ability to innovate and growing data use, um, about infrastructure capabilities up there, and that at some point that it strikes me as, and you see some firms doing this now, sort of exploring these the capacity of putting more data processing in orbit, so that a lot of what you're doing doesn't even have to deal with sort of the latency effect of coming down to Earth, but a lot of that processing happens in situ, in orbit, and comes down. And I just kind of wonder if you can kind of, and maybe Marshall, this is a good place for you to sort of jump in. What does that look like as you have more and more sort of advanced technologies, and the capacity for even just like basic server farms up in orbit that are starting to do a lot of the processing work that traditionally has been happening down here terrestrially?
Yeah, it's really interesting. I was just talking to Roger Hunter, who Dan may know. He actually is a alum here of the University of Georgia. He's at NASA Ames, and we've entered a realm where you will have onboard processing. You don't have it. I remember when I got in this game, you had to send stuff down to the ground and back up and then produce a graphic. I think we're very much in an era where we'll have onboard processing of data and production of the real-time product on the satellite, as opposed to processing it on the ground. I think we're in an era of autonomous swarm capacity for some of these small sat networks and constellations and so forth. So it's an exciting time, and I want to sort of use my hat as an associate dean here at the University of Georgia and a professor. It's an exciting time for some of these technological areas. If there are any young listeners or any parents or any college students, aerospace engineering, computing, computer sciences, data science, AI, these are realms that are going to be needed, because some of these same capacities are cross-disciplinary. I mean, some of the same problems that Dan or Ray are working on for satellites or other technologies are just as needed in sort of self-driving cars or in autonomous systems here on the ground as well. So I encourage sort of, one of the things that I think we probably need, and in the same way that we have a World Meteorological Organization, I think we need to think sort of globally how to harness the capacity that we have around the planet in these spaces. I mean, I don't know what that looks like yet. I was recently at a meeting with someone, and they were talking about there's no real global harnessing function for GIS, Geographical Information Systems processes, in the same way that we have a World Meteorological Organization or a World Health Organization. Maybe we do need some kind of a World Technological Organization to sort of, I don't know what that means or looks like. I'm spitballing, but I think we're in an era where there's enough momentum and movement in this space that we're going to have to think carefully about how we coordinate.
So I'm not going to let you get away with saying autonomous swarms without without some questions on that.
Yeah, I mean, and Ray probably could talk to this as much as I can. And GPM is a constellation. I mean,
Sure.
NOAA's.
I think the question that I have, because obviously, you have so much going on up there, and it doesn't make sense from a pure operational standpoint to not have these things being operating autonomous, given just like the intersection of how, frankly, how much math has to be done to kind of make sure these things don't intersect. The question that I have actually comes like when they do accidentally intersect, and like the potential fallout and problems, and how profound that actually is, given how many other systems are in operation up there, from things that have to do with our basic telecommunications, really kind of tenets of the economy and defense and security. So, all of these things have to be sort of interoperable in a way that makes sense. And how does that work when you have different systems. I'm talking not only in the commercial sense, but internationally. The Beidou network in China. You have all of these systems that don't necessarily talk to each other in the same way that they do in partner countries. So, Dan, I don't know if you want to address that, or Marshall, if you could. I'll sort of leave the floor open.
Well,
Yeah, go ahead, Marshall.
go ahead, Dan. Oh, I'll jump in. I mean, I think in the same way that sometimes we don't talk to and hear each other down here on issues that matter, that have nothing to do with space. I think we've just have the technological version of that up there right now, and that we do have sort of constellations and swarms and so forth. And there's different sides, and there are different companies, and there are different countries. And that's why I said we've got to think carefully about how we coordinate across this space, or we're going to run into the same issues of communicating and not speaking each other's language and hearing each other. And I'm not necessarily meaning hearing from the standpoint of just hearing with your ears, but understanding the differences and so forth. I mean, that we see here on the planet. I think we've got differences in terms of how our sort of space environment is evolving as well. And so there are issues that will require governance in the same way that we talk about climate and extreme weather governance. We're going to have, I think we've sort of in the space technology and space governance 2.0 era. And again, I'm not the person that's going to figure that out or have a solution, but I think it's platforms like this where we throw these types of things out there, and smarter people than me that are listening. And
See, I don't know. I might push back on that a little bit, because it does seem like the nature of these, what have been these individual fiefdoms, operating somewhat autonomous for so long, are becoming by nature more interdisciplinary. So someone like you, I imagine, would have quite a lot to say, or anyone on this panel would have quite a lot to say in terms of it, and do it in a very sophisticated way. But it's almost like we've had, scientists and policymakers and industry all kind of working separately for a while. I mean, obviously there's crossover naturally, but just the intersection of all this seems to be happening at a much more advanced pace, in tandem with a series of technologies that are advancing rapidly. We haven't even talked about quantum on this call at all, but that's for another webinar. I think we're about 1:45. We're going to go to audience questions very soon. I did want to ask one sort of more open-ended question to you, Ray, as sort of maybe a summation in terms of this kind of harkens to something I asked you earlier. But if you were to look at the space and you look at sort of the intersecting government interests and how they meet with commercial interests, what's the future look like? What put rub your crystal ball here and bring us down the road.
I think we're at the beginning of a really profound change, meaning that the change of the pace of change is going to accelerate significantly. That's driven by AI and new space, I think, for the most part, right? We'll see far more data that's really useful and needed for these models, and there's no magic around it. Like, no AI can solve without the data. And we'll see these models that can run 1,000 times faster or, at 10 times the resolution, and resolve for much finer phenomena and get really incredible performance. And that all of this great technology is going to translate, and that's really the key to things people can use. And so I'm hopeful that 5 years from now, we can solve a lot of the global sensing and modeling gap, and provide reliable weather forecasts, reliable early warning systems to the 5 billion people who today don't have it. I think if we achieve that, that will be phenomenal, and I think we have the tools to get there.
Dan, same question to you.
Yeah, I mean, I do agree with Ray. Things are changing very quickly, but I think we're on the right track to continue to really harness these new technologies. I think it's on NOAA's plate to a lot of things, but one of them is collecting the observations. This is the backbone of the forecasts that are made, and even our partners in Europe are taking data from NOAA observations, and NOAA's taking data from European observations, and the private sector. We absolutely do data buys from the private sector and use those in the model as well. So I think we're on the right track, and I think there's going to be a lot of innovation here over the next 5 to 10 years.
Okay, so let's go to audience questions now. We have some of these get somewhat specific. So I'm going to throw this one to you, Dan. This is from Tyler Johnson, and he says, "I'm intrigued by the effectiveness of radio occultation (RO) in predicting severe weather. To what extent is RO data currently being utilized for forecasting severe weather events, and what specific improvements have been observed in prediction accuracy?" I don't know if you can address that for
Yeah,
us.
so I don't know I guess the detailed answer to that question, but I will say that radio occultation data, I believe it's true that NOAA is purchasing that data from a private company or more private companies and using it in the models. This is one of the pieces of information that gets assimilated into the models, and it is improving the forecast. And certainly severe weather is one of the categories that it is improving. I don't really have any specifics beyond that.
Okay.
I can jump in there a little bit.
Sure, that'd be great.
I mean, so Dan's right, but there are also several studies out there. As soon as that question popped up, there was one that I remember seeing in somewhat of a review process. I mean, even as recently as a couple of years ago, just showing numerically how radio occultation is and GPS signals are being used to improve weather forecasting through numerical modeling. So
It may be good for us to actually help define that for those in the audience who are not familiar with that term.
well, I think and Dan might be able to, I don't want to sort of get it too wrong here, but I think that there's some use of the sort of attenuation of GPS. People probably have some familiarity with GPS and how that operates. And so that microwave or that electromagnetic energy, as it's propagating from satellite to receiver, there is an attenuation. If you've had a satellite television back in the day, you probably were familiar with losing your signal when it rained because of its attenuation. Well, in a similar manner, I think we can use that loss of information and signal to gain information on things like how much water vapor may be in that atmospheric column intervening. And so that kind of information can be utilized. So there are scholarly studies that show the value of that. And Dan's right. I think there is I recall there's a private venture between NOAA and a federal and private vendors on that particular data set.
All right, the next question I'd like to go to you, Ray, in this sense, because I think it would be really interesting to get a private sector answer to this. But this is from John Fisher, and he says the vast majority of funding of new weather satellites is for large government-owned exquisite satellites. What advice would you give to sort of new policymakers regarding the accelerating of the development of commercial weather data constellations, so that if you're in a position now where you can be advising, future administrations or something to that effect in terms of what this private sector needs to accelerate your own development, where would you start? How would you approach that?
First, I have to swear that I didn't plant this question. It came organically. I think just look at examples in other domains, right? Launches used to cost the government between $500 million to $1 billion per to LEO. They're now less than 10% that number, right? It didn't happen on its own. It happened because NASA decided to give SpaceX a shot and gave them the first contract, right? And lo and behold, they delivered on it. And now we've got this crazy period where putting things in orbit costs 10% what it used to cost a decade ago. We're expecting the same to happen again. Similarly, the advice I would give the government in this context is you have a lot of needs, right? They're mapped in the decadal surveys, in the DoD side, etc. Don't try to solve all these needs with your existing model of cost plus. It's a failing model. It failed over and over and over again. We have a new administration that's pushing you to save money. Give it a shot. See what we can do, right? Like, take some more money. I'm not saying all of the budget, but divert some money to the commercial programs, a little more than you do right now, and open up the mission statement to like solve my sensing problems. Who can do this, who can do that, and see what you get out of private industry. And I guarantee you that 5 years from now we'll see 10x improvement in performance relative to what we currently have.
Cost plus is such an interesting one. I mean, it almost seems like the focus, and not almost, it does seem that the focus has been to move away from cost plus contracts, and yet you do have these legacy projects that are not that easy to unwind, given the nature of how Capitol Hill works and the nature of, sort of the intersecting interests of stakeholders. Marshall, I wonder if you could sort of address that same question in terms of sort of guidance for helping the commercial sector accelerate.
Well, as an academic, I probably have to take a little bit of a sort of objective, generic viewpoint there, but I will say this, and this is something that I've written about in Forbes over the years. I view weather information as a public good, in the same way that if my house catches on fire, I want a firefighter to show up, or I want the police to show up. But even in that public good process of that firefighting and that police response, there are private sector aspects that sort of enabled and enhanced, and in some cases improved the public sector. I want to kind of build on that model. I want to expand on that model where it makes sense. But I think Ray agrees with this as well, because you even heard him mention the fact that he sees the private federal sector as a potential customer for companies like his. So there has to be this sort of, I don't want to say symbiotic relationship, but there has to be this relationship that is emerging and improving, where it makes sense, the private sector might be able to innovate faster. But at the end of the day, I still view weather information as a public good.
Right. All right. The next question here is actually from an anonymous attendee. This is reinforcing Ray's comment. Gaps in data are larger than ever, which then force forecasters to interpolate missing data with models, which may or may not represent reality. And so he's essentially saying, what is the value then of filling these gaps with low latency, high resolution data, and what type to make these forecasts better? And also, these data sets are essential for training AI and machine learning. I think he wants to kind of get at the value of training real data versus model data. And Dan, maybe that's a good place for you to jump in. If not, then we can pivot to others in the panel to discuss.
Yeah, I mean, the questioner, the anonymous attendee asking the question, is absolutely right. There still are gaps, and I think that it's our job as a group, all of us on this call, to help fill those gaps in various ways. I mean, we can do that observationally with satellites. We can do that from the ground. We can do that with various ventures from the private sector of things like radio occultation data, and other innovative ideas. So I think it's upon all of us to do a really good job of trying to fill those gaps. And NOAA has its plans, and GeoXO in the future, like I mentioned, as well as. And another question I saw come in has to do with low Earth orbiting data. I failed to mention the importance of those technologies as well. It's not only geostationary, but the low Earth orbiting satellites are collecting some critical data as well.
Right. That's the next webinar that we have coming up. No, I'm kidding. Last question here. This is at least last audience question. This is from Andrew Rodriguez. And maybe Marshall, this is a question that you can take. This centers on a lot of what we've talked about in terms of like the ethical considerations that go into AI and its modeling and the data sets that are used and sort of the inherent limitations with some of them. But Andrew's asking a very specific question about, have there ever been any issues with corruption or bias with AI processed data that have sort of led to real issues or concerns, or are we still kind of in this theoretical construct here? But from a pure sort of a weather analysis perspective, or from where this could head, are we looking at something that has happened or foreseeing issues down the road?
Yeah, there are verification studies afoot on that very topic right now, and I'm certain that there are biases that have been revealed.
Yeah.
Even, I mean, look, nothing is the perfect panacea cure-all here. Even as we know AI can provide, there are still going to be biases. The forecast is still, I mean, there are inherent, remember, AI and machine learning is learning from data sets that are inherently imperfect. And so in that there those imperfections and those sort of resolution biases and other types of sampling biases and so forth are still there. Are they perhaps mitigated some? Absolutely. But I would say that we are a little bit beyond the we're sort of the mad scientists in the lab testing things out. I think we do have some understanding of where the skill set can be improved, but absolutely there are still biases that are apparent and present.
You know, the mad scientist question, I think, is or at least there's a reference, is a perfect kind of way to shape this up. And Ray, I'm kind of go to you with this, because you and I have talked about this a little bit, but you know, all of this has been centered terrestrially here on Earth. But as new technologies take shape, and as commentaries from those like Elon Musk talk about settlements on Mars, you know, Rocket Lab is planning a private mission to Venus. There is going to be increased considerations that kind of extend beyond what NASA's already doing in terms of weather patterns on other celestial bodies. And I just wonder, at least in terms of, you know, real forward-looking kind of commentary. And you know, I know this doesn't factor into your business plan right now, but I'd like to kind of get a sense of, like, when we hear terms like lunar economy, and you hear things like Martian settlements, and you hear what Peter Beck is doing at Rocket Lab, does that sort of kickstart some gears turning in your own mind?
I think you know, we don't have any intentions of getting into deep space anytime soon. I would say though that the notion of private companies, again, working with government, but taking a much more substantial role in sort of expanding the reach of science, not just like solving for a very specific commercial use case, is fascinating, and I think really opens up a lot of opportunities. And I think we're going to see that in the remote sensing world, in the earth sciences world as well. Sort of private companies doing things that maybe are more on the edge of the science side. They're interesting for NASA from an exploration standpoint, but they can also bring about really big, you know, businesses, and that can happen not just on Earth, but let's start with Earth.
I think that is a perfect place to leave it. We are right at time here, so I just want to thank our panelists, thank all of our attendees. Certainly thank BAE Systems who has sponsored this panel. We try to do these at least twice a month, if not more in the future, and it's a great forum to kind of discuss all these sort of different intersecting components of what's happening in space, how that affects Earth, and then sometimes talk about what's happening elsewhere, like what we just did just now. So I want to thank everyone who joined us, and that's it for us today. We'll see you next time. Thanks so much.